you like f of x equals, let's say, 2/5 x. So how do I know if it's growth or decay? Good. Whatever's being raised to the power. So if there's a number in the front here, it doesn't impact whether it's growth or decay, right? It's whatever's being raised to the power. So that 2/5 raised to the power falls in between 0 and 1. If it's in between 0 and 1, is it growth or is it decay? It's decay, okay? And then from there, all you have to do is do your t-chart. So I'm going to give you the same points that I gave in the video yesterday. -2, -1, 0, 1, and 2. And you do the same thing. So you're just going to plug those points in. So I'm going to start with -2. So 2/5 to the -2. And what happens when you raise an exponent that's negative? Say again? Well, in this case, I have a number in the top and the bottom. So what's going to happen there? It flips it. So it's the reciprocal. If it was a 1 in the top, or the number in the top, then it just goes to the bottom. If there was a number in the bottom, it would just come to the top. But in this case, I don't have a 1 in either space. So I'm going to flip it first. So the first thing I'm going to do is do the reciprocal, which would be 5/2. And then raise it to the second power. So this is 5/2 times 5/2, or 5 squared over 2 squared. 5 times 5 is 25. 2 times 2 is 4. Now when I go to graph this, I'm going to need it in mixed number format. So how do I get 25/4 into a mixed number?
4 goes into 25.
Yeah, 6 times, and then it'd be a remainder of 1, and that 1 goes over the 4. So 25/4 is really 6 1/4. All right, so I'm going to take and plug in each variable, or each point. So I did -2, I got 25/4, which is 6 1/4. If I did 2/5 to the -1, what do I get from there? 5/2, right? So the negative on the outside just flips what's on the inside, and anything raised to the first power is itself. What is 5/2 in terms of a mixed number? 2.5, or 2.5. You could write it any way you want to, as long as you know how to graph that point. So 2.5. And then 0. Anything raised to the 0 power is what? 1. 2/5 to the first would be? Anything raised to the first power is itself, so 2/5. And then 2/5 squared would be 2/5 times 2/5, or 2 squared over 5 squared, which is 4 25ths. So now I've got my chart. Questions so far? How many of you have the chart right? Okay, good. Any questions on the chart before I graph it? Okay, so now I'm going to graph it. So I'll give you the coordinate plane. This would be -1, this would be -2, this is 1, this is 2. And then look at your points. I'm going from, 4 25ths being the smallest all the way up to 6 1/4. So I want to make sure I can at least get 1, 2, 3, 4, 5, 6 to the 7. So at -2, my point is 6 1/4, which is about here. At -1, my point is 2.5, 1, 2.5. At 0, it's 1. At 1, it's 2/5, which is small, close to the x-axis, but 4 25ths is even smaller and even closer to the x-axis. And we said this is decay, which makes sense. It should be decreasing as I move to the right if it's decay. Questions on that one? All right, so the first thing you want to do is identify growth or decay. Is this growth or decay? Growth, which means if I put my points correctly, I should be having an increase as I move from left to right. All right, so then I do -2. So 6 to the -2 is what? 1/36, right? So the negative brings it to the bottom. This would be 1/6 squared, which is 1/36. with me so far? Yep. All right, negative 1. 6 to the negative first, it would be what? 1 over 6. So that 6 goes to the bottom. 6 to the first power is still 6. 6 to the 0. Anything to the 0 is 1. 6 to the first. 6. 6 to the second. 36. Okay, then I want to draw my graph. Still going to go negative 2 to positive 2. This time I have to make my way all the way up to 36. So I can go by 5s if you want to. 5, 10, 15, 20, 25, 30, 35. So you can mark it however you want. Just be consistent. Like watch your spacing. Kind of make sure that it's spread out. I'm going to give you a coordinate grid on this and the quiz. Just make sure that if you change the the y values that you mark what they should be. If you're going by 2s, you're going by 5s, so that I know what you're supposed to be doing. Okay. All right. So negative 2 and 136 means that it's really close to my x-axis. Negative 1 and 1/6 is a little bit bigger, but still pretty close to my x-axis. 0, 1 puts my point about a fifth the way up that line. 1, 6. And 236, so there's a big jump there. And then we said this was growth, which makes sense. This is increasing as I move to the right. Any questions? Everybody's good on graphing. So again, that's what the homework for tomorrow. That's the homework assignment will be given. You'll get 2 graphs. Okay, should be super easy. Just be careful when you're plugging in your points. And all you need to know is, the difference between growth and decay, and then how to graph it. All right, so we're going to finish. Okay, we started with all differential functions, and we're going to get into growth and decay functions when you're creating them and information based on them. So a constant increase or decrease. And Mr. Falcone said he touched on it a little bit with you guys yesterday, right? So which was news to me, the change in, which I'm actually super curious to find what other changes there are. The change in SAT brought on this. So previous to the new SAT, there wasn't a whole lot of growth and decay. Like maybe you got a model and you had to talk about it. Is it increasing, decreasing, that kind of stuff. What he said yesterday is that now you're seeing the actual where you have to come up with the growth model or the decay model, which is like, give me the equation that would form this. So this is actually super important. It's funny because I said on a normal year you would kind of touch on it and not put too much emphasis. But now that it's changed, obviously, it's something that you definitely want to pay attention to. So a constant increase or constant decrease is exponential, meaning that if I had, I talked about it a little bit on the video yesterday, but if I'm having something that's constantly increasing, right? So there's this thing, I don't know if you've ever seen it, but if you put $1 in a piggy bank or a quarter in a piggy bank every day, even if you started at a penny, if you had a penny today and then you doubled it tomorrow, it was 2 pennies, and then you doubled it, now you're at 4 pennies, and then you double it, now you're at 8 pennies, that you could have a significant growth by the end of the year. You'd be putting a lot of money away by the end of the year because it's an increase on something that's already changing. So it's not just saying add 1 each day. It's saying take what you've got and double it. Take what you got and triple it, that kind of thing. So when you put money in a savings account, or if you have a credit card and they have interest charge, this is what's happening. So you're getting interest charge on what's already there, and then as it continues to grow, you're getting interest charge on the new amount. So all of that is increase or decrease, okay? So the way that you set up a model is the initial amount. So whatever amount you're starting with is your initial amount times 1 plus or minus the rate of change. So think if it's growth, it's going to be a positive change, right? So I would get plus the rate. So if I'm in a savings account earning 5% on whatever I've got in there, I'm going to take whatever money I put in initially times 1 plus the interest rate. If it's a decrease, so things like cars depreciate in value, electronics depreciate in value, they become less valuable as time goes on. And let's say they depreciate at a rate of 3%. Now that's a minus because it's a decay, okay? So the growth is plus, the minus is decay. So this starts by saying write a function to model the growth in the value of the investment and then solve it. So it says Clara invests $5,000 in an account that pays 6.25% interest per year. After how many years will her investment be worth $10,000? So the first thing we want to do is, first of all, it states it in the beginning, but it's obviously growth. It's continuing to growing 6.5%. But when I set it up, so my initial times 1 plus the rate to the t, which is however many years it's in there. So what's the initial amount that she's investing? So this 5,000 is my A. What's the rate in which she's investing? 6.25. So what's the catch here is this rate has to be in decimal. And what does it give it to you in? Percent. How do I get from decimal to percent? Multiply, well, divide by 100, or move my decimal 2 places to the left. Okay? So this is really, move it back, 0.0625%. Or decimal, sorry. And then the T is however many years her investment will be in there. So I can say 5,000 times 1.0625 raised to the power of T is going to give me how much her investment is worth. And that's going to change based on the T. So anything like this, you would have a calculator for. Okay, this is obviously not something I expect you to do without a calculator. And you'll see this in a couple of different ways. It will either say, tell me what the investment is after 10 years. And for that, I would say that the T is 10, and I would plug it in. 5,000 times 1.0625 to the 10th power. So if you want to get out your calculators. So if it gave you the T, you'd be plugging it in. If not, then you can use the graph of the function to find the actual value on your graph. So we're going to do both today. We're going to say, this is what would happen if I gave you the T, which is this case, and then I'll show you how you would find it using the graph, okay? So let's say I asked after, year 10, what would her investment be? Then I just do 5,000 times 1.0625 to the 10th power. So this is when you get to know your calculator, because if you have to raise 1.0625 to the 10th power first and then multiply by 5,000, then you want to make sure you do it in that order. So the graphing, like the iPad calculator will make you do that first, 1.0625 to the 10th, and then take that and multiply it times 5,000. Most graphing or scientific calculators can do all that in once. So 1.0625. So this should be $9,176.68. That would be after 10 years. So if I didn't have the graphing component to this, I can almost do a guess and check, right? Like if I'm already at 9,000 at 10 years, I'm not that far off from from $10,000. I could add in maybe another year, maybe another 2 years and see where I'd be at. But if you do have the graphing component of your calculator, then you want to go to your graphing calculator. It's going to say y equals, and you'll type 5,000, 1.0625 to the power of x. Actually, make that an x, not a t, because that is your variable.
When it says be worth $10,000, does that mean at least $10,000?
Right.
Like the closest amount you can get to.
Right. Because it didn't say how many years. Like you don't have to do like a 0.2 years.
Okay.
Yeah. Okay, so I just went out into the graphing calculator app and I graphed this, and now I've got it. I zoomed out on it so that I got where the 5,000 hits. So the goal is for your investment to be worth $10,000. So if you zoom in on this, you've got a trace feature on your graphing calculator in which you can trace along your curve. That's one option. You would trace it until your y is 10,000. Okay, something like this, I would kind of approximate my 10,000 is about here, which means if I draw that all the way down, it's happening just past 11 years. So like 11.2 years, 11.3 years, something like that. Okay. So on your test, because not all of you are required to have a graphing calculator, you would probably see something more like, I'm going to give you T, and you tell me how much the investment is at that point. So you'd just be plugging it into that function. So you'd have to come up with a function and then plug in your T years, however it is. Okay. For homework, when it's asking you to use the graph to do it, if you don't have a graphing calculator, use that app. snapshot it, bring it in so that you can make sure that you learn how to read these graphs, because that's also part of standardized testing, is if they gave you the graph, could you read it, okay? So my answer here would be just over 11 years, like 11.2 years, approximately, something like that. Yep.
The graph is not showing up now.
Is it, how's your window?
Like,
Okay, so this one says, write a function to model the growth or decay. So this time it's not telling you growth or decay. You've got to figure out, is this going to be something that's increasing or is this something that's decreasing? And then solve it. So a city population which has initially 15,500 people has been dropping 3% a year. What does dropping tell you? This is a decay, okay? So this graph, when I graph it, should fall as I move to the right. Write an exponential function and then graph the function and use the graph to predict when the population will drop below 8,000. So see if you can come up with your function on your own. Remember, we need initial, and then we need the rate of change. And we need to know if that rate of change is positive or negative. So this would be what? Negative. Good. And then if you've got a graphing calculator, practice plugging it in. If you don't, go to the app. So you need to have one or the other, a handheld graphing calculator or the iPad app. And it's free Graph Calc if you don't have it. It's free space GRA Calc. So what was my initial population? 15,500 times 1, and we said this is a decay, so this would be minus. That 3% would look like what in decimal form? 0.03, good. And then it would be time, would be t, but when we type it in the graphing calculator, we're going to do 15,500. And you can even do 1 minus 0.03, or I can do 0.97x. You can do the work first. All right, so I did the graph. I zoomed in on, or zoomed out on it really, to get to that. I made sure that the 15,000 was in sight, because obviously if I'm zoomed in to 10 to 10, it's not going to be there. And then I used the trace feature to find as close as I could get to where 8,000 would be. So I'm right about 8,001, 8,002, which is pretty close. And I know from this that the year, which is up here, or I can align it with my x-axis, is about 21 years. So we're going to say approximately 21 years is when the population of this is going to decrease to the point in which it would hit about 8,000. Yep.
My graph does not look that.
All right, so this one says a motor scooter purchased for $1,000 depreciates at an annual rate of 15%. Write an exponential function and graph the function. Use the graph to predict when the value will fall below $100. So growth or decay? Decay, which means it's going to be the A, 1 minus the rate to the power of t. And what did it start as? 1,000. So my A is 1,000. 1 minus 15% is what decimal? Good. 0.15 raised to the t. So I'd get 1,000. And again, you can type that in as your calculator like that, or I can make it 0.85 t. And then I would type that into the calculator. So I went to the graph, I graphed it, I zoomed out, I traced it, and my goal is for the y to become less than 100, which means it's going to take a little bit longer than where I'm at right now. So a little bit more than 14 years, right? Or over 14 years. So again, that would be, again, everybody's got a graphing calculator, that would be the prediction. A question more like one that's something you would see on the test is if I said, how many scooters are going to be purchased in 3 years from now, okay? And so if I said that, how would I use that information? So if I said, how many Predict how many scooters are going to be sold 3 years from now. How do I use that information? What does that 3 represent? The T, or the time, right? So I take that whole model that I just made, and I plug the 3 in for T. Yep.
When would you have to do, when would T be negative?
If it said, so that would have to be like a where it was 3 years ago.
Okay.
Would be a negative. So it's a great question.
Okay.
Yeah, like, so if this is where it's at now, what were my scooter, approximately what my scooter sales were 5 years ago. And then that would have been 5 years from now backwards would make my exponent negative, which you won't see a lot in a model like this. You will see stuff on like radioactive decay, that kind of stuff you might see. But that would be, if you're going back in time, would be when it was negative.
Would I ask us a question like find the difference between how it was 3 years ago versus what we like 3 years in the future?
This is a great SAT question. Yeah, so that's it. I don't know if ever you heard that, but what's the difference between what it was before and where it's at now? So if I said 2 years ago, then my T would be -2. I'd plug it in, I'd get the decimal for it. And where it is 2 years from now, now I'd make T2. So this is more accurate of what you would see, because not all of you have a graphing calculator. On a in-class test would be something like that. Like if T is 3, then what is it? So I would do 1,000 times 0.85 to the power of 3, and I would get 614. And I can't sell 0.125 scooters, so I would say that this is 600. And if it's a scooter, right, and I'm saying exactly 3 years, then I would want a whole number. Does that make sense? So you wouldn't give me a 0.125 of a scooter. So it would be approximately 614 scooters.